Welcome! In this lesson, we will build a clear visual understanding of first-order differential equations. We will compare homogeneous and non-homogeneous linear equations, explain the structure of a linear first-order differential equation, and then practice solving problems using the variable separable method and the integrating factor method. A linear first-order differential equation has the form y prime plus p of x times y equals q of x. Here p of x and q of x are known functions of x. If q of x equals 0, we call it homogeneous. If q of x is not 0, we call it non-homogeneous. We will see examples of each and how to solve them. Some first-order equations are separable. A separable equation can be written as y prime equals g of x times h of y. We separate variables by placing all y terms with dy on one side and all x terms with dx on the other side. 1 over h of y times dy equals g of x times dx. Then we integrate both sides. The integral of 1 over h of y equals the integral of g of x dx. Let's solve a quick example by separation. dy over dx equals 3x times y, with the initial condition y of 0 equals 2. Now, let's connect this to linear equations. The general linear form is y prime plus p of x times y equals q of x. If q of x equals 0, the equation is homogeneous linear, and it often separates directly. Y prime equals negative p of x times y. If q of x is not 0, we use the integrating factor method. We'll do one example of each. Homogeneous linear example, y prime plus 2, y equals 0. This can be separated as y prime equals negative 2y. So 1 over y equals negative 2 dx. Integrating, we get ln of absolute y equals negative 2x plus c. So y equals c times e to the negative 2x. Non-homogeneous linear example, y prime plus y equals e to the x. Here p of x equals 1, and q of x equals e to the x. The integrating factor is mu of x equals e to the integral of p of x dx, which is e to the x. Multiply the entire equation by mu. E to the x times y prime plus e to the x times y equals e to the 2x. The left side becomes the derivative of y times e to the x. Now integrate both sides with respect to x. The integral of the derivative of y e to the x equals the integral of e to the 2x dx. This gives y e to the power of x equals 1/2 e to the 2x plus c. Finally, solve for y. Y equals 1/2 e to the x plus c e to the negative x. Summary. First, identify the type. If it is separable, rewrite with all y terms with dy on one side and all x terms with dx on the other side. Then integrate. If it is linear first order, write it as y prime plus p of x times y equals q of x. If q equals 0, it is homogeneous and often separable. If q is not 0, use the integrating factor mu of x equals e to the integral of p of x dx. These simple checks guide you to the right method quickly. Great work today building intuition for homogeneous and non-homogeneous linear equations and practicing the separable and integrating factor methods. Keep practicing, and these patterns will feel natural